Hello students, today we will take the important part in the model application, the side plate concave convex mold parts, as an example, to learn the preparation of the processing technology of the side plate concave convex mold parts. As shown in the figure, the side plate concave mold parts, the technical requirements are CR12MoV. Heat treatment requires quenching 58 to 62 Hc. The edge size of the parts is matched with the punch and the die. The double-sized clearance is 0.08 to 0.12 mm, and the rest of the surface roughness is Ra 0.8 micron. Second, process analysis. We first conduct a process analysis on the part. Starting with an external analysis, the part has typical characteristics of a stamping die convex part, and the side plate, convex and concave parts are made of CR12MoV material. Heat treatment, quenching 58 to 62 HRC. CR12MoV steel has high hardenability and can maintain good hardness and wear resistance at 300 to 400 Celsius. Its toughness is higher than that of CR12 steel, and the volume change during quenching is minimal. It can be used to manufacture various molds and tools with large cross-sections, complex shapes, and withstand large impact loads. The surface roughness of the cutting edge working surface is Ra 0.8. The shape of the part is relatively regular, but there are two small straight segments and transitional arcs on the right side of the part. Due to the straight edge of the part, some common machining methods are difficult to choose. According to the characteristics of wire cutting machining technology, it is more suitable to choose wire cutting machining for the processing of side, panel convex, and concave parts. Dimensional analysis shows that this part is a working part of the stamping die, and the dimensional accuracy directly determines the dimensional accuracy of the product part. Therefore, the machining accuracy requirements for the part are high. From the figure, it can be seen that the cutting edge of the feeding convex die and the cutting edge of the punching concave die are on the same part, and the consistency of the two recognized dimensions needs to be ensured through machining process. This is because the size of the cutting edge of the part is 0.08 to 0.12 from the double-sized clearance of the punch and die. If there is a deviation in the cutting edge, it will cause uneven punching clearance, directly affecting the dimensional accuracy of the product part. The highest requirement for dimensional accuracy of the parts is the surface roughness Ra 0.8 of the two holes with a diameter of phi 9.1 and the upper and lower planes around the parts. The surface roughness of the cutting edge of the parts is ensured through wire cutting precision machining, and no grading is performed after wire cutting. Material analysis shows that the side panel concave convex mold parts are made of CR12MoV, which has been heat-treated and quenched to 58 to 62 HRC. CR12MoV has high brittleness, good hardness, and wear resistance, high toughness, minimal volume change during quenching, and can be used for manufacturing various molds and tools with large cross-sections, complex shapes, and withstand large impact loads. Third, determine the process routes. After analyzing the process of the side panel concave-convex mold parse, we will determine the machining route of the parse. The selection of the blank. From the figure, it can be seen that the overall size of the side panel concave-convex mold parse is 126.3 multiple 38.3 multiple 48. With a relatively simple geometric shape, the parts require high hardness, toughness, and wear resistance. The blank is cut using foggings. So C-Art Wall Movie is selected as the blank, and the fogging size is 170 multiple 60 multiple 53. The determination of the surface processing plan, combined with the structural characteristics and occurrence requirements of the side panel concave-convex mold parse, requires that the side panel concave-convex mold parse undergo ordinary rough machining first, and then use precision benchmarks for subsequent precision machining. According to the previous learning and table lookup, the processing plan for the side panel concave-convex mold parse is milling, plane grading, drilling, wire cutting. The arrangement of cutting sequence is based on the principle of face first, hole second, and reference first. Based on the technical requirements of the side panel concave-convex mold parse, the cutting sequence of the parse can be arranged as follows: fogging cutting milling, six-sided flat mold, upper and lower side reference, machining center point hole, points threaded hole, threading hole, reference hole, feeder, drilling expanding hole, tapping serrate, flat grading, upper and lower side reference, wire cutting. According to the requirements of heat treatment for the concave-convex mold parts of the side plate, the annealing process should be arranged after the rough machining of the entire part, and before grinding and wire cutting. The arrangement of auxiliary processes includes inspection of workpieces, deburring and cleaning, in order to ensure the processing quality of the side panel concave-convex mold parts, and avoid the generation of waste products. The inspection and processing route of the entire part should be determined after all processes are completed, based on principles of comprehensive cutting processing sequence, heat treatment process, and auxiliary process agreement. The processing route for the concave-convex mold part of the side plate is finally determined as follows: fogging cutting, milling six size, flat grading, upper and lower size, side reference, machining center point, hole points threaded hole, threading hole, and reference hole, feeder, drilling, expanding, threading, heat treatment quenching, flat grading, upper and lower size, side reference, wire cutting, part shape and punching concave mold hole, inspection and storage. Preparation of processing technology. The preparation of processing technology for side panel convex and concave mold parts, based on the drawing requirements and processing route arrangement of the side panel demolding parts, we first determine the two benchmarks of the part, as shown in the Hole A and Plan B in the figure. The processing technology process for single-piece production of the side panel convex and concave mold parts can be formulated as shown in the following table. Process 1. Material preparation. Prepare C-Art Wall Movie fogging material 170 multiple 60 multiple 53. Process 2. Milling six size to remove roughness, leaving a margin of 0.3 to 0.5 on one side of benchmark B in the process diagram, and leaving a margin of 0.5 on both the upper and lower sides. Process 3. Flat grinding. grinding the upper and lower surfaces with a size of 48.5, ensuring surface roughness. Grinding the side surface B benchmark. Smooth surface is sufficient. Process 4. Machining center. Point holes. Diameter 9.1. 3m8 threaded holes. Drilling and ringing reference holes. A. Diameter 6 with a depth of 10. Process 5. Feeder. Drill 3 to M8 threaded bottle holes. Tap 3 to M8 deep holes with a depth of 20. Expand 2 5-10 holes. Drill a threading hole with a diameter of 9.1 and a diameter of 5. Process 6. Heat treatment. Quenching 58 to 62 HRC. Process 7. Flat grinding. Grinding the upper and lower surfaces to ensure surface roughness and size. Grinding the side surface reference B. Process 8. Wire cutting. Based on A and B benchmarks. The shape and hole of the wire cut part are 2 to 5 9.1, with clearance between the die and punch. Finally, inspect, verify, and store the parts to complete the machining process. Classmates, that's all for today's class. See you in the next class.